In this problem, we're going to do two things. We're going to calculate z-scores or convert data values into z-scores. And secondly, we're going to use the empirical rule graph to find percentiles for certain data values. Well, the problem says the lifespans of a species of fruit fly have a bell-shaped distribution. We have a mean of 33 and a standard deviation of 5 days. The lifespans of 3 randomly selected fruit flies are 35, 30, and 46 days. Find the z-scores that corresponds to each lifespan and determine whether any of these lifespans are unusual. Well, we have a bell-shaped curve, and within 2 standard deviations of the mean, 95% of the data lies. Anything outside of the 2 standard deviations is considered unusual. The z-score is the number of standard deviations a value x falls from u. The formula is that z equals the data value minus the mean divided by the standard deviation, or x minus mu over sigma. Well, if the data value is 35 days, we plug in 35 for the data value. The mean is 33 and the standard deviation is 5. The calculation turns out to be 0.4. We can do that again for 30 days. So z equals 30 minus 33 divided by 5. That's a negative 0.6. So far, both of these z-scores are within 2 standard deviations, so they're not considered unusual. 46 days, z equals 46 minus 33 divided by 5 is 2.6. That is greater than 2 standard deviations, so that data value is considered unusual. Now, the second part of this problem, the lifespans of 3 randomly selected fruit flies are 48 days, 23, and 43 days. Use the empirical rule, find the percentile that corresponds to each lifespan. Well, I'm going to pull out my empirical rule graph. Okay, let's see if we can line this up conveniently. Okay, for 48 days, we want to convert the data value into a z-score. Z equals 48 minus 33 over 5, which is 3 standard deviations. Okay, go down to the graph. 3 standard deviations is all the way out to here. We want the area to the left. Well, the area to the left is 100% minus the 0.15. That's going to give me a percentile of 99.85%. Doing it again for 23 days, z equals 23 minus 33 over 5, which equals minus 2. All right, that's negative 2 standard deviations. That puts me right here. We want the area to the left. That's going to be 0.15%, 2.35%, and we're going to be 2.35. So that total is 2.5 percentile. Lastly, if we have 43 days, z equals 43 minus 33 divided by 5 equals 2 standard deviations. 2 standard deviations positive from the mean puts me right here. We want the area to the left. So we're going to take 100%, all the area, minus these 2 little blocks, which is minus 2.35 minus 0.15%, gives me the 97.5 percentile.